Serious, scientists of Reddit, what's craziest or weirdest thing in your field that you suspect is true but is not yet supported fully by data? Educational psychology. There is a fringe theory regarding the origin of ADHD, ADD, that I find really fascinating and think probably has something to it. It says that ADHD, like many other disorders, is possibly an evolutionary adaptation that certain people have which provides a pro in addition to a con. You see, lots of, sometimes terrible, genetic disorders do have an upside. Sickle cell anemia patients, for example, are more resistant to malaria. Cystic fibrosis patients are more resistant to salmonella. So what would ADHD's upside be? Awesome hunting abilities. In tribal hunter societies, someone with a looser attention span, who is able to react more quickly to moving stimuli, would likely be the best hunter in the group, and would get showered with riches and women. Now, all it gets you is frustration and medication. By the way, one of the coolest pieces of evidence for this theory, albeit anecdotal, is that kids with ADHD tend to be abnormally good at first-person shooter video games. TLDR. One theory says that ADHD is an evolutionary adaptation to improve hunting ability. I am a student in meteorology. This is more of a technological advance than something that needs to be proven. Within the next 10-20 years, most cars or cell phones will have microchips in them whose sole purpose is to record the current data, such as temp, wind, etc. This will allow for millions upon millions of data points, which in turn will greatly increase the grid spacing for forecast models. In layman's terms, forecast accuracy and forecast personalization will be near pristine, down to the seconds. Microchips are already cheap enough. We just need the proper computing power to process all of that data in real time. Supercomputers to the rescue. I work in numerical weather modeling. Specifically, I work in data assimilation. The shortcomings of weather prediction aren't driven by observations over land, but rather over water. The advances over the past 15 years have come from passive measurements of radiation from space. From an observation standpoint, the next major weather forecasting jump forward will occur when we figure out a way to effectively measure the wind in the tropics. Since geostrophic balance is inapplicable there, Doppler wind lidars are the best technology we have in development today to do that. But I have my skepticisms on its practicality. Geography. That you can figure out the routes illegal immigrants will take in crossing borders on foot based on hill slopes. Initial data seems to confirm it, but there's so little work done on it out there. Basically, as far as we can tell, human beings will avoid steep stuff at all costs. The problem is that most studies are done on concrete with established pedestrian areas. And you can't just ask an illegal immigrant to tell you what route he took on foot, because most of them actually don't know. Biology, immunology. So much of our adult health is based on things we encountered during early childhood, but we are only starting to realize the extent of it. Most basic science done in animal models focus on adults. Even when trying to model pediatric disease, it is becoming clear that our immune systems are drastically different as infants, and we need to tailor vaccines or other preventative methods to address this. Biomedical science. Giving Viagra to pregnant women will help combat obesity. It is well known in science that being born small or growth restricted is strongly correlated with later obesity, hypertension, heart disease, and type 2 diabetes. These babies are ill-equipped for the calorie-rich world in which we live, and as a result their bodies preferentially store fat and essentially gobble up any glucose or fat that enters their bodies. A huge amount of the obesity we see today may be due to growth restriction. Viagra works by opening up the blood vessels in the penis to allow an erection. Viagra could similarly open up the blood vessels to the placenta and therefore the baby, providing them with more nutrients in the womb to help them grow. We are currently testing this theory in mice, rats and sheep. Clinical trials in humans about to start. Close bracket. The Americas were inhabited by humans at least 30,000 years ago. Possibly up to 60,000 years ago or more. Lots of archaeologists whisper this in hushed voices. But there are so many entrenched detractors that there's no way for this to become accepted until the current older generation die off. Edit. 60. 000 is kinda at the boundary of possibility. Dates of around 30. 000 years in age are expected by a sizable number of archaeologists studying pre-Clovis material. A lot of people are asking me questions that I have tried to answer elsewhere, so please read through the commentary to see a list of some of the sites and dates in question. How the debate is currently framed. My opinion. Some opinions that agree with me as well as a few voices in opposition. Hopefully most of your questions should be answered there. Astrobiology, planetary science. There are most likely billions of Earth-like planets in the galaxy, not really controversial. But so far observational data has not found many. This likely a technological or methodological shortcoming rather than the product of a representative sample, and that life, perhaps not advanced or intelligent, likely exists on many of them. Biology. When personal genomic sequencing becomes readily accessible, even as a routine medical service, much like a physical, we should be able to place the data into a controlled anonymized database and use statistical analysis to essentially link most disease states and predispositions to their genotypic bases. There are loads of combinatoric black holes in the genome data right now. Since we haven't been able to collect large-scale, high-throughput disease genotype relationships on a genomic scale yet due to the expense. Have a look at the company 23andMe for an example of a smaller scale version of this. They represent a good first step towards breaking the cost down and making personal genomics accessible regardless of socioeconomic status. Chemistry. A lot of the accepted mechanisms for the way reactions occur are incomplete at best. Example. Water and alkali metals go boom. The accepted mechanism is that the metal dissolves and loses an electron which goes to an H+ to make H, which combines with another H to make H2. Then the heat causes the H2 to combust. However, recent observations of various colors associated with metal vapor evolving during the reaction suggest the metal may be vaporizing at the interface with water and that this reaction is occurring in the gas phase rather than a simple dissolution of the solid and subsequent electron exchange. Edit. So a lot of people don't like the alkali metal with water example. So here is a bit about my own research. I am working with a material that has been known since the 50s. It wasn't thought to be too exciting, but we understand more about the mechanism by which it forms now. We have been able to use this knowledge to add a simple compound to the mixture that actually slows the formation of the material. This has led us to creating the highest resolution photoresist in the world. I am studying in a relatively new field of science called astrobiology and just finished my first internship of all my studies. This is what caught my attention. In 2004, the spectral signature of methane was detected in the Martian atmosphere by both Earth-based telescopes as well as by the Mars Express probe. Because of solar radiation and cosmic radiation, methane is predicted to disappear from the Martian atmosphere within several years. So the gas must be actively replenished in order to maintain the present concentration. Edit. TL Doctor, I truly believe we will have confirmation of life outside of planet Earth in the next 2-3 generations. Chestnut blight was introduced to the United States in the early 1900s and since then, all American chestnuts in much of the U.S. cannot mature properly and will die at a nearly uniform stage in development. Much of the work I did in college was looking at the issue of the blight. My masters took me to propose that the chestnut gall wasp has a direct link to developmental challenges introduced by hormonal changes within the chemistry of C4 pathway photosynthesis. These changes are directly influencing a protein coupling mechanism failure and aiding the blight of the chestnut. My doctoral thesis is showing this without a doubt and will soon present ways to offset the population growth of the gall wasp and will soon allow chestnuts to be regrown naturally. They will then dominate our landscape again as they did early in our history. I have a personal specimen in the Smithsonian credited to my professor and I for being the first ones to document the gall wasp this far north on the easy coast. Edit. Whoa. Gold on my chestnut work? Thank you everyone for your interest in Castanea dentata. I cannot link my master's thesis yet because it is still well within the depths of peer review. My doctoral thesis is what I am working on now. As soon as this info becomes available I am going to share with you guys. Thanks. Oceanography. For some reason this crazy idea isn't being supported. Myself and almost every other oceanographer suspect it to be true. However, this theory isn't being bought. Life as we know it in the ocean is undergoing drastic change due to overfishing, increasing acidity, rising temperatures, and pollution. Even if drastic action is taken it will be too late. I believe it. Other scientists believe it. But the general population is too f***ing lazy and misguided to realize that you can't wait around for someone else to solve these problems. Yes, I am bitter. Mathematics. This is kind of meta. It's about the science itself. Most people work in only very specified area. It is very difficult to understand what somebody else is doing. Sometimes even if he works in the same field as you. The problem is that people are doing exactly the same stuff sometimes, but using a complete different language, which makes it impossible to recognize that that is the same stuff. This is especially frustrating when you try to find out if somebody already solved the problem you are working on. People are aware of this problem, but nobody talks about it or do something about it. My guess is that many people are simply afraid of the possible consequences. To find out that the problem you have been working the last 20 years has been solved 40 years ago by some other guy. Things like this still happen sometimes. Evolutionary biology. Everything that makes us placental mammals and different from marsupials, like the kangaroo, may be due to sexually transmitted diseases. Recently we've found that integral proteins in the development of the placenta have their origin from a retrotransposon, essentially a virus that embedded its genes in our genome. Viral genes in animals is actually pretty common. Ever have a cold sore? The virus is laying dormant in your cells right now. So that's not the weird part. You see 9,999% of the time, these genes don't get transmitted vertically, from parent to offspring, because you would have to infect the gonads in order for it to present in gametes, sperm and eggs. And that aren't exactly prone to want an infection. And right now most infections of those areas are STIs. Even weirder? People have detected something similar in mice. Makes sense. Rodents aren't too distantly related to primates. But it's an entirely different f***ing gene. But still is absolutely integral to placental development in mice. Evolutionary anthropologist here. It is not supported by data. But I believe that within social groups, aggression and cooperation are counterintuitively linked in the following way. If experience with interpersonal aggression prepares individual group members for competition with other groups, then cognitive, cultural, and endocrine mechanisms supporting aggression toward fellow group members may have been favored by natural selection of traits, whether cultural or genetic, because disharmonious but well-trained groups outperform harmonious but poorly trained groups. The interesting thing about this hypothesis is that if the cooperative consequences of heightened intragroup aggression bear no net benefits to the actor, then not only could some intragroup aggression be an example of cooperation, it could be an example of altruism. I find this last bit unlikely, but philosophically intriguing. Physicist astronomer here. It's amazing how people find the concepts of dark matter and dark energy so captivating and mysterious after watching a couple documentaries. Always quick to believe them. In reality, dark energy and dark matter are pretty much just placeholder concepts for stuff we have no idea on. We don't know why the physics of a galaxy and its tussles with gravity are the way they are. By calculations, there's not enough mass for the galaxy to be the way it is. So we just made up dark matter to explain that phenomena. We can't see this unseeable matter that accounts for the extra required mass for our calculations to work. Archaeology, the theory that civilization and city-states began at a set time in ancient Mesopotamia will be discredited soon. Cities like based around the ever-changing position of the Tigris and Euphrates, have been found first not because they were first, but because those cities were easiest to find by archaeologists because they were abandoned when the rivers moved. I think civilization will soon be pushed back to a much earlier starting point, as older cities are rediscovered in areas more geographically stable, and thus weren't abandoned and so obvious to find. Geology. For me, it's that earthquakes can set each other off in chains. And when an earthquake occurs, it transfers stress along a fault line, or reallocates it to another area. There is very limited data on this, other than fringe science documentaries on the Discovery Channel. I imagine that within my lifetime, we will have an accurate way of measuring stress allocation on the Earth's crust, and thus be able to verify that earthquakes can, and often are, sequential. Cancer biology. Traditional chemotherapeutics will rarely be used as first-line therapy for cancer in the not too distant future. This is already becoming a reality for certain cancers. In the next couple years, this will be the case for some blood cancers. There are very promising small molecule inhibitors in phase III clinical trials, which have been very effective in combination with monoclonal antibodies. As cancer therapeutics become more specific, safe, and efficacious, traditional chemotherapeutics will be used less and less. Not to mention cell-based therapies, such as transfusion of CAR T cells, which are improving and hold considerable promise in addition to new pharmaceuticals. This post is likely to get buried at this point, but I can't resist sharing my excitement. I am ecstatic about the notion that I'll be able to offer my patients an orally administered pill with minimal side effects versus traditional chemotherapy. Biology. The mutation that causes Asian glow may have been responsible for wiping out malaria in Eastern Asia. Human aldehyde dehydrogenase 2, ALDH2, has a mutation common in Asian lineages that is known as ALDH22. This causes the enzyme to be less able to convert acetaldehyde, a toxic compound present in alcohol, to acetic acid and other non-toxic metabolites. Malaria is a parasite that does not have a high resistance to acetaldehyde in the host body, since neither the host nor the parasite are able to process the acetaldehyde. The malaria is unable to survive and was thereby wiped out, assuming the people in the past drank a lot of alcohol. Microbiology. The microbiome, the collection of bacteria your body harbors, will likely come to be recognized soon as a previously overlooked variable in determining what diet is truly healthy. How certain diseases work, like Crohn's disease and ulcerative colitis, and even how certain drugs are metabolized. Scientists have known for some time that your body contains more bacterial cells than human cells. But only recently did they appreciate that the species of bacteria present vary widely from person to person, and are heavily influenced by a number of environmental factors. Personally, I favor the view of looking at the microbiome as if it is another organ that can malfunction like any other. Physics. Antimatter and matter might not have a normal gravitational attraction between one another. They might not interact via gravity or even repel one another. Common thought is that the interactions are identical, i.e., they attract one another. However, due to the difficulty in creating, trapping and cooling antimatter to the temperatures low enough to test a force as weak as gravity, this has not currently been tested. This actually has some profound consequences on the universe as a whole. The question of why is there lots of matter and hardly any antimatter is solved. The antimatter is repelled from our matter side of the universe, which now has a dipole-like structure. Additionally, things like solar positions require an understanding of gravity because the sun is so massive. If they attract, only some positrons have enough energy to escape. If they repel, all positrons that get to the surface escape. Genetics. As the volume of completely sequenced individual genomes increases over time, we will gain a better understanding of the frequency of disease-causing alleles in our species. It will become apparent that disease-causing mutations, or at least what we consider to be diseases causing, are more prevalent in healthy individuals than previously measured. This will spark a greater interest in understanding the epigenetic status, whether a particular gene is turned on or off, of the entire genome. And subsequently technologies will be developed to rapidly sequence the epigenome, The epigenome of an individual differs by tissue and cell type, and even by ag. And so sequencing will need to be performed on many different types of tissues from a single person. TLDR. Deep sequencing of DNA is just the tip of the iceberg. Eventually epigenomic sequencing of various tissue types will be standard practice in medicine. Biology immunology. The hygiene hypothesis. Humans evolved with helminths and other microorganisms in their systems which modulated the immune systems that we have today. With the increasing cleanliness of the Western world, it's the very absence of these organisms in our bodies that is causing our immune systems to function improperly and result in autoimmune disorders. I feel like in the next few decades more evidence for this hypothesis will be published and therapies using worms or specific proteins might become the norm for treating autoimmune diseases and allergies. Biology toxicology. Based on unpublished research I conducted during grad school, I believe that a possibly significant part of the diabetes vascular disease epidemic is the result of toxins, in particular arsenic in drinking water, altering the fenestrated epithelial cells lining the capillaries of our liver. Essentially, cells lining the little blood vessels in our livers are full of holes to allow the blood to be cleaned by liver cells. There has been some research showing that arsenic in drinking water, at levels well below those recommended as safe by the WHO, causes these fenestrations to close. We found these animals gained abdominal fat, the really dangerous kind between your internal organs, and had liver cells with significantly increased concentrations of giant lipid droplets. Among other things, there is also some correlation between diabetes incidence and living in an area with high arsenic concentrations in groundwater. Neuroscience. This is unrelated to my actual field of study, but I've been doing a lot of reading about communication between the bacteria in your gut and your central nervous system. It's turning out the types of bacteria that make up this community actually have a lot of influence on your physiology outside of digestion. This is leading to the idea that some bacteria, probiotics, or the good ones, can actually be administered to treat mood disorders like anxiety and depression. The weird theory part of it is that some of these bacteria actually produce neurotransmitters like GABA and serotonin. Since nobody really has any idea how gut bacteria interact with the nervous system, it's been proposed that they actually directly communicate using these neurotransmitters. So, literally, your stomach and your brain can talk to each other, and their conversation influences your mood. Prion biology. Although a species barrier exists that slows or seems to prevent altogether the spread of prion disease between species, it is likely that chronic wasting disease, CWD, a prion disease affecting deer, elk, and moose, will jump to humans and or to cattle, and then to humans. Currently, bovine spongiform encephalopathy, BSE, or mad cow disease, is the only known non-human prion disease that can be transmitted to humans. And people have stopped paying much attention to the very rare cases of variant CJD. But when CWD crosses the species barrier, the shit will hit the fan. And due to the length of the incubation period in humans, on the order of years, it is my guess that patient 0 has already consumed CWD infected deer, and either isn't showing clinical symptoms yet, or is showing symptoms that are being incorrectly diagnosed as something else. Business administration. Corporations will start to be measured and graded by how productive they are in a scale immediate global community. Basically, crowdfunding will begin to start, maintain and break entire business companies. It's basically going to be the foundation stone of capitalism 2.0. It's going to absorb principles of communism into itself, making transparent models of managing so rooted no one will be able to tell what a company isn't doing. Just so you have an idea, we're looking at an immediate future where a consumer receives a code which lets him access how and when a dairy product was made, together with on-demand access to the manufacturer's CCTV, yes, even the slaughterhouses. Tissue engineering. We are going to find a biological recipe for creating self-assembled tissues from scratch. Developmental biological processes can turn a single-celled zygote into an adult human. It's pretty damn incredible when you think about it. Somewhere buried in the complexity of metazoan biology are a set of origami-like rules that allow growing tissues to self-assemble into larger tissues and organs. If we can model and manipulate these programs with precision, we can engineer just about any tissue we like. A lot of people are familiar with 3D organ printing as a route to organ manufacturing. But I think it's a dead end without more knowledge of biological self-assembly. If we can't control how tissues develop, the organs will fall apart as soon as they are printed. The missing pieces of tissue self-assembly are quantitative models for tissue morphogenesis, which are being filled in as we speak by advances in vitro tissue culturing and molecular biology, like viruses that can measure gene activity over time with good spatial resolution.